Welcome to another episode of the Practical SQL Server HADR show. My name is Edwin Sarmiento, and welcome to this episode. Yeah, I should probably start calling it episode. If you are joining in for the very first time, welcome. Thank you for taking the time off of your busy day to listen and watch. If you're watching it live, taking the time off of your busy day to learn from the things that we share through this specific channel. The goal of this entire show, the Practical SQL Server HADR show, is twofold. One, if you are taking care of or responsible for any type of SQL Server high availability and or disaster recovery solution, whether that's an always-on availability group or a failover clustered instance, or maybe a combination of both. I still see those out in the field. And you're in the process of either designing something that you want to roll out in production, or you are implementing it. You already have something in production. Somebody took care of the design, they just gave you the blueprint, and now you're implementing it in production. Or you already have one in production, but either you're struggling with management, somebody else deployed it, and they left you trying to figure out how it works, or you are experiencing outages after outages and are unaware and have no clue at all what is going on underneath. This is for you. The goal is for you to learn from not just my personal experiences, but also from those of my customers' experiences, the projects that I've worked on in the past. But not only that, we kind of look at learning as something to learn from the good things, right? We rarely look at learning as learning what not to do. I'm also going to share with you some of the things mistakes that I made so that you can avoid them. In fact, the topic of today's conversation is all about pitfalls that you need to avoid if you're implementing some form of a high availability solution for your SQL Server databases. Now, I did say it's twofold. First is for the technical professional responsible for the care and feeding, the implementation. The other one is for decision makers, for executives, whether you're a database lead, meaning you are leading a team of database professionals, DBAs, even developers, or you're the director of IT, or you're the VP of engineering, and you're thinking, is this the solution that we need? I kind of joke around the fact that the technical decisions are being made in golf courses, and I just don't know how to play golf. I was at a workshop, running a workshop a couple weeks ago at a Microsoft campus, and they were all complaining about, yeah, we were pushed to deploy X, whatever that technology is, and all we have to do now is to accept the fact that we have to not just deploy it, but to take care of it. Okay, and again, the reality is a lot of these decisions are being made in the golf course, and that maybe the executive is playing golf with the salesperson from either Microsoft, Oracle, AWS. We don't know. But at the end of the day, is to give you insights as to whether this is something that is really meant to solve your business need, right? And I don't recommend always on available group lightly. In fact, I don't default to recommending it unless I understand clearly what your business requirements are and whether or not it really is the right solution for you. And again, for decision makers, this is to give you guidance, right? And also look at whether or not your team is ready. They've already built the entire solution. Are they ready to take care of it moving forward? The last thing you want is, of course, to have, again, somebody come in, build the environment, build the infrastructure, yet your team is not ready for it. Okay, I did say part of what I share in these episodes are not just this is what you need to do, but also this is what your not supposed to do. Like kind of like realizing that there are some things that you need to avoid in order for you to have a working, stable, reliable, and highly available solution for your SQL Server databases. And again, I don't want to be kind of like a negative person where I'm only looking at the bad side. No, the reality is this: there's no such thing as a perfect solution. Okay, there is no such thing as a perfect solution. So you would, whenever you're implementing something, you have to be ready for not just the good things, but also the bad things. I mean, the reality is SQL Server high availability and disaster recovery exists for that very reason. Or any type of high availability and disaster recovery exists for that very reason. Something will go wrong. It's not a question of if, but a question of when. So today's episode is really all about the failover clustering trap you're walking into. I just want to highlight the fact that if your goal is to provide high availability to your SQL Server databases, whether that's through always on available groups or failover clustered instances, the idea behind that is SQL Server does not really provide high availability. It doesn't. Okay, there's this common misconception that SQL Server provides high availability. Although when you look at the fact sheet and the list of features, it lists as high availability features, failover clustered instances, always on available groups. True, those are high availability features. But the reality is it's not SQL Server providing those, providing high availability. It sits on top of a platform called a Cluster Resource Manager. Of course, because SQL Server has been running on Windows for almost forever, because now you have SQL Server on Linux, that Cluster Resource Manager is the Windows Server Failover Cluster. SQL Server simply relies on the Windows Server Failover Cluster to take care of high availability. So when you think of it this way, there is coordination between SQL Server and the Windows Server Failover Cluster in order for the databases to be highly available. On its own, it cannot even do that. Okay? SQL Server has to rely on an existing platform to achieve high availability. And again, this is a misconception because most of the time in organizations where you have segregation of duties and you have large teams, the database administrators will deploy or implement always on availability groups, and everybody else will depend on the SQL Server databases, or in this case the DBAs. They will take care of making sure that databases are always highly available, not realizing the fact that if something happens to the underlying infrastructure, like in this case, the Cluster Resource Manager that is a Windows Server Failover Cluster, you're toast. And because these segregation of duties exist, these silos where sysadmins take care of the Windows Server Failover Cluster, DBAs take care of a SQL Server and the databases, the segregation of duties and these team silos are what cause outages to the SQL Server databases, because one team is not aware that what they're doing is causing issues. Okay? And this is what this whole episode is all about. Failover clustering trap you're walking into. And again, I just gave you kind of like a high-level overview of how things work in the context of providing high availability to SQL Server. That's also one of the reasons why I really hate the idea when Microsoft introduced the concept of read scale availability groups, because the name in and of itself, availability groups. Wait a second. I've known availability groups since SQL Server 2012 and it's highly available. And now I have read scale availability groups and you're telling me it's not highly available? Again, that's part of what Microsoft, the marketing team at Microsoft is responsible for, like the naming and all. And that's also one of the reasons I highlight to customers, you have to read the fine print, because read scale availability groups is not designed for high availability. Anyway, let's get back into this. The failover clustering trap you're walking into, because again, before you implement always on available groups and or failover clustered instances, you need the failover cluster as the platform providing high availability, fault tolerance, resiliency, and automatic failover, health detection even, to your SQL Server databases. And while I want to get deep into this, in fact, I will be doing a 1-hour presentation for the PASS Summit on tour on the internals of Windows Server Failover Clustering and how it interacts with always on availability groups and failover clustered instance to provide that very feature. Okay, so again, it's not SQL Server providing high availability, it's Windows Server Failover Clustering providing high availability to SQL Server. So what are these traps? There are traps that you have to be aware of, because the most common thing that I see is there will be a request, let's provide availability groups, let's deploy availability groups or failover clustered instances. Let the Windows team, or we can even backtrack a bit, let the VM admins provide us with virtual machines. Let the come up with a template with the right vCPU, hopefully not under provisioned, and also hopefully not oversubscribed. The VMs will provide the virtual machines. Then the sysadmins will step in. They would configure Windows. They would build Windows Server Failover Cluster, test that it's highly available, and then hand it off to the database administrators, where they will install SQL Server, they will configure always on available groups and test it as well. Because these are things that you have to be aware of when you deploy always on available groups, failover clustered instances on top of Windows Server Failover Clustering. And while I would like to talk about Linux, there's still very few in the market where they would use a Linux pacemaker for running SQL Server always on available groups on Linux. Okay, so what are these failover clustering traps that you are walking into? Hopefully you have your pen and paper ready. Take notes. This is trap number 1. The illusion of high availability. What do I mean by the illusion of high availability? And again, you have to look at it from both any kinds of implementation, whether it's a physical implementation, you're running it on a physical machine, or running it in a virtual machine. Again, the bigger challenge there is somebody else is taking care of like hardware provisioning, and then somebody else is also taking care of Windows Server operating system installation and configuration and failover cluster implementation as well. And then somebody else is taking care of SQL Server. In those cases, everybody has this understanding that these databases are going to be highly available until they're not. And more often than not, when things go sideways and the databases become unavailable, it's the DBAs that get blamed. It's SQL Server that get blamed. It's also why there is this running joke about the other meaning of the acronym DBA. It's the default blame acceptor. They always, and I initially thought for the longest time, I thought it was just a joke. But when I started getting brought into projects and had to work with different teams, I started to realize it was not a joke. Anytime that the databases become unavailable because of an outage, or even performance issues sometimes, or security, they always blame the database. It's SQL Server, to a point where my job has now become the legal counsel for SQL Server, trying to prove that SQL Server is innocent, because by default, database server is guilty until proven innocent. Okay, so what is this, again, illusion of high availability? The fact that you deployed a Windows Server Failover Cluster and ran stuff on top of it makes it highly available. You have to understand the inner workings of Windows Server Failover Cluster in order for you to really be able to provide high availability. I'll give you several examples here and piggybacking on what I've already mentioned earlier about the segregation of duties. First off is you're running failover clusters and availability groups on VMs. So there's a separate team that deploys the virtual machines. Again, separate team that takes care of installing Windows, taking care of the operating system, patching, installing Windows Server Failover Cluster, and then there's a DBA team responsible for the availability groups. But then VM admins are not aware that there is this thing called availability groups inside. They just do what they have been doing for ages, meaning deploy servers, making sure that they're up and running, consolidating, making sure that they're making the most out of their investments. The goal of virtualizing stuff is to keep data center costs low. Hence, I mentioned about under provisioning and over subscribing and all these different things, because this is how they see the world. They look at the entire data center and see web server number one is not using up too much resources. We'll under provision this. Okay. Same thing with VM admins. They see SQL Server as taking up, or during startup, barely taking up 1/2 of RAM. This machine is not taking up RAM. We'll under provision it. But they're not understanding what's happening underneath. Okay. More common issues that I see here is when a VM admin deploys, for example, a 2-node failover cluster with a 2-replica AG, and they do not even configure anti-affinity. So a 2-node Windows Server Failover Cluster and a 2-replica AG, you still need a tiebreaker. Hence, you introduce another virtual machine with your file share witness, but there is no anti-affinity configuration on all 3 VMs. So there will be cases when all 3 VMs would end up on the same physical host. What's the point of having a failover cluster inside your VM when your physical host becomes a single point of failure? Okay. Again, part of the illusion of high availability. And you have to keep in mind that the reason why you have an always-on availability group, the reason why you have failover clustered instances, is because you want high availability. And in order for you to achieve high availability, you have to eliminate single points of failure, right? Single points of failure. I learned this when I was working as a data center engineer. Man, it's been years. Where we do DR tests on a quarterly basis. We are mandated. We have to follow compliance requirements every quarter. And while we were failing over servers, apps, everything else, the network guy was sitting there doing nothing. And all of a sudden he had this epiphany where he was saying, wait a second, why am I not doing anything? It's as if we're assuming the network's going to be available when a real disaster happens. So he recommended one day when we were doing DR exercises, why don't we take our main network switch offline? That's when we found out that the main network switch became the single point of failure because it did not automatically fail over. And these are things that you have to really think about when you're implementing a high availability solution, because it is easy to fall into the trap of having that illusion of high availability. Another example I can think of, which I've seen in the early days of always-on availability groups, SQL 2012, SQL 2014, SQL 2016. Unfortunately, I still see it today. Okay, I still see it today. Again, going back to that example of SQL Server being deployed on virtual machines, VM admins would take VM snapshots for backups, or the enterprise backup team would use a virtual machine backup technology. I don't want to name names, but I've seen those cases, Veeam, where they would use this enterprise backup utility backup tool for the VMs, and all of a sudden, everything goes offline because the enterprise backup utility would saturate the network, causing heartbeats between the nodes in a failover cluster to not make it in time. Okay, there's a default setting. It's 10 seconds now with Windows Server 2019 and onwards. 10 seconds. So if the virtual machine backup or snapshot will take more than 10 seconds, the cluster will take itself offline because, well, I can't talk to node 1. The other node would say, I can't talk to node 2. So what does the cluster do? It will take itself offline. The very first case I worked on this was back in 2014. Customer had SharePoint, of all apps, SharePoint multi-tier application running their databases on an always-on available group. And every 8 p.m., mind you, I already knew when they said every 8 p.m. Every 8 p.m. their entire SharePoint farm goes offline. And I kind of already have an idea of what's going on, because what is going on at 8 p.m.? But the idea, the behavior was such that every 8 p.m. their entire SharePoint farm will go offline. And this is a global company. So users cannot use SharePoint for a good 5 minutes. 5 minutes. When I asked what's going on at 8 p.m., well, they said, well, the backup, enterprise backup is running, which is taking a full-on VM backup, and it takes, on average, back then, 40 seconds. I know you can tweak those settings now. 40 seconds. So if your heartbeat configuration is set to 5 seconds, meaning the nodes in the failover cluster need to hear from the other nodes, they can talk to each other. If nothing, no messages were exchanged within 5 seconds, the cluster will say, I can't talk to this guy. Let's get rid of it in the cluster because we need to be healthy. But then they cannot talk to every member of the failover cluster. And so what happens? Well, I can't talk to anybody. I think I'm the only one alive. I'll take myself offline. And because the SharePoint databases sit on an availability group, the cluster took itself offline, even though there was nothing wrong with SQL Server. The databases were healthy. SQL Server was healthy. But the fact that always-on available groups was sitting on a failover cluster and the cluster lost quorum because of this enterprise backup, took itself offline. Okay, and I could list so many more examples, but this is kind of like the illusion of high availability. Just because you have high availability on the hardware level, on the network level, on the OS level, like in this case, Windows Server Failover Cluster, on the database level, doesn't mean you will be highly available. There are factors outside of your control. Other things that other teams are not aware of. Like in that case, the enterprise backup team did not know that whatever they're doing is causing outages to the databases and the entire SharePoint farm. So that's something which leads me to point number 2. It's the cross-team miscommunication and blind spots. Again, cross-team miscommunication and blind spots. I already gave you examples from the previous point of the illusion of high availability, where you have segregation of duties. And I was just talking to a customer the other day where they're looking at deploying an always-on available groups, but somebody else is deploying the VMs, somebody else is taking care of the operating system, and the database team will be responsible for availability groups, and they're not talking to each other. Right? The database team will be responsible for AG, but wait a second. You should bring those people involved. You should bring them in conversations, because whether or not they know about it, whatever they'll do will cause issues to your databases, and at the end of the day, you're going to get blamed for it because it's databases. Okay, so cross-team miscommunication and blind spots. What are these? And I've already mentioned a couple of them, like the sysadmins. Okay, they're performing a maintenance. They're doing configuration settings, like that example that I mentioned. VMs, you got 3 VMs in a 2-node failover cluster with a file share witness, but they're not configured with anti-affinity. So you end up having all 3 VMs in the same physical host. What happens when they decide, hey, I want to reboot this physical host. Well, if you're using VMware, VMware HA can take care of moving the VMs around, but sure, that will still take time, but there will still be an outage. Okay. One thing that I see a lot is, again, VM admins will deploy the VMs, Windows Server admins will deploy the failover cluster, and then they would hand it off to the DBAs. The DBAs, not knowing how everything is configured underneath, like, is the failover cluster properly configured? Is the witness properly configured? I even saw somebody the other day say, hey, we want to put an Active Directory on one of our nodes. I'm like, oh, why? Well, because this is an isolated network and this is the only app that requires availability groups, and we don't want to provision an additional VM. Like, they don't know, again, because these are different teams not talking to each other, they don't know that you cannot do that within, well, I don't want to say you cannot, because you can always do anything with a couple of workarounds. The question is it supported? Okay, there's a big difference between I can do it versus it is officially supported. So stuff like Windows admins deploying failover cluster, but not understanding how SQL Server works or how availability groups work under the covers. They're not aware of the internals. A common example of this is they would perform a maintenance. Maybe they're installing a Windows security update. Maybe they would bump up the CPU count, because I don't recommend hot swap of both memory and CPU on VMs. Not recommended at all. There's a lot of people say, hey, we can avoid powering down the VM and powering it back up after we've added or removed vCPU and vMemory. True, but that puts an additional performance hit on VMs. Anyway, maintenance. So they're performing maintenance, and they assume rebooting this VM, because it's a failover cluster, right, will automatically fail over the AG. Nope, it doesn't. A failover cluster will not automatically fail over an AG unless 5 conditions have been met. If you have been watching a lot of these videos, I did a video a couple of weeks ago, or months now maybe, on those conditions that have to be met in order for automatic failover to occur. So again, typical maintenance, I would patch the secondary node, reboot, fine, the AG is running on a node number 1, patch node number 1, reboot, and then all of a sudden, your databases are offline. You're kind of wondering, wait a second, how come the databases did not fail over? Isn't this what availability groups is supposed to do? Isn't this what failover clustering is supposed to do? Yes, unfortunately, it did not meet those conditions, 6 conditions. It did not meet those 6 conditions for automatic failover to occur. But they are not aware of that. All they are aware of is that failover cluster will just do its thing. Again, the illusion of high availability coupled with cross-theme miscommunications and blind spots. Okay. Another example of that is, again, over-provisioning or under-provisioning VMs running AG replicas. This is really still fresh because of that conversation I had with a customer where they are running SQL Server on VMs that are under-provisioned, and they complain, why are my apps slow? Why are my queries slow? They talk to the VMs and say, oh, we don't see anything on vCenter. Everything looks normal. But what the VM admins see in vCenter or VMware vCenter versus what SQL Server feels inside the operating system versus what Windows sees from a performance perspective, unless you have something that collects all that information and aggregates them and analyzes them, you would all see different things. SQL Server will feel like, I don't have enough resources. VMware would display, hey, you have more than enough resources. And unless you collect information, data, and metrics from both SQL Server or all SQL Server, Windows, and VMware, and then correlate all of those three metrics, that's the only time that you can have a better picture of what really is going on. I've seen cases where VMware admins would push back and say, no, we've given you more than enough CPU. I don't see anything on vCenter. I don't see anything on a dashboard that tells me there's something wrong with the VM. But then your queries are taking longer. There's no amount of indexing or query optimization that would help because you don't have enough resources. Okay, and again, cross-team miscommunication. Another example there is no one team understands and owns the end-to-end failover path. Somebody reached out to me a couple of days ago asking about, hey, I really wanted to understand how this whole thing works because they're only responsible for SQL Server, not realizing that your listener name is an Active Directory object. So what happens if you don't have Active Directory when you failover? Yes, that is part of the whole high availability solution. But unfortunately, and I've learned this decades ago when I was managing failover clustered instances, when SQL Server does not see, or in this case, the availability group listener name does not see an Active Directory domain controller as it's failing over, because that is a computer object, which means it needs to authenticate. Then it could, and I say could because Microsoft made some changes to how the caching of credentials worked. It could fail when you trigger an automatic failover. It may not even go online. The listener name, that is. The IP address is fine with the DNS client cache, but the listener name might not even come online. So if your client applications are refreshing their DNS client DNS record, and they cannot find the listener name, then they can't connect to it, and that has nothing to do with SQL Server. That's Active Directory. Okay, so the entire end-to-end path on how this thing works. Networking, as I mentioned, in the illusion of high availability, where the enterprise admin will take backups, something that they do on a regular basis. They would take backups, not knowing that the amount of time it takes to back up a VM live as it is in production, the amount of time it takes for them to take backups would affect heartbeat. As a side effect of affecting heartbeat, the cluster will lose quorum, take itself offline, taking the databases offline with it. Again, not a SQL Server problem. It's a failover clustering problem showing up as a side effect of someone else doing what they do all day or every day. Okay, just taking backups. And we need to take backups. Those guys are just doing their job, but they are not aware of how things are working underneath because they never had those conversations with the database administration team, the Windows sysadmin team, the VM admins, and the enterprise admins. Okay, so bring people in the conversation. More often than not, when a customer would reach out to me, it's typically the database administration team. It's the database team lead reaching out to me. And more often than not, they're not aware of what's happening within the infrastructure. They're not aware that, oh, the VM is configured with X amount of vCPU. That they can see from inside SQL Server and inside Windows. But what about vNuma? How is vNuma configured? How is anti-affinity configured within the VMs? They are not aware of that. But the VM admins are not part of the conversation. They have to bring those people in. Okay? That is cross-team miscommunication and blind spots. And I can go on and on with just the fact that the teams are not talking to each other. And this solution is not a one-team implementation. Everybody on the team, the Active Directory team, the DNS team, server admin team, virtual machine admin team, enterprise backup team, Windows and SQL Server database team, they have to be involved with this. Oh, not to mention the operations team, because once you cut over to production, they will be the one responsible for assessing whether or not the alerts that they're getting, the tickets that they're receiving, fall into SQL Server category. And I've seen cases where they've set up the alerts, they've set up the monitoring tool, but when these alerts come in, the operations team don't even know whether the issue pertains to SQL Server, pertains to Windows, pertains to the VM, and so they would just escalate it. And the time it takes for them to escalate it to the time the right team manages to get a hold of that ticket, minutes, sometimes hours. The escalation process takes hours sometimes. And it defeats the very purpose of high availability. Okay? So cross-team miscommunication and blind spots have to be nailed down from beginning up until you roll it out in production. Third thing here is operational assumptions, and I'm tying it all together because by the time you deploy always on available groups, failover clustered instances, or any type of SQL Server high availability solution, you will have to deal with operations. Okay? Cutting over to production is one thing. Most of the time, implementation projects are so focused on the implementation that they forget there is operations and day-to-day care and feeding. I see this a lot, especially in cases where somebody else, an external consultant, a managed services provider, a contractor, a vendor, implemented high availability solution, and then they hand it off to the customer, but with no proper handoff, meaning there is no inter-team communication about how this entire solution works, not bringing in the backup team, not bringing in the VM team, and everybody is in the same room with having the same conversation. This is huge because just because everything worked after production cutover doesn't mean it will stay that way. It is part of your responsibility, the day-to-day responsibility, to make sure that you're not making wrong assumptions when it comes to operations. I've already mentioned one earlier about installing patches. Okay, Windows admins take care of Windows patches, so they would install patches, and sometimes, okay, without the proper change management process. Again, assumption: I have VMs. I will install a security patch on this VM, not knowing that this VM is currently hosting the primary replica of the availability group. Reboot. Again, that's part of the day-to-day operations. Reboot. Oh, we'll assume that failover cluster or the AG would move to the other node. It's not moving. Why is it not moving? Why is it not failing over? Again, because it didn't meet those 6 conditions. So it will not automatically fail over. Okay? Or even worse, they just reboot, not realizing that there is an availability group or a failover clustered instance running on that particular machine. Okay? Another example, your network admins deploying firewall rules that eventually block port numbers like 3343, the port number that Windows Server Failover Cluster uses to communicate with each other, and 5022, the port number that SQL Server uses to do replica communication and data replication traffic. The network admins are simply doing what they're doing. They're simply, maybe the security team advised them, hey, we need to block these port numbers. So they're simply doing what they needed to do as part of their day-to-day operations, not knowing that there's an impact. There's a side effect of them deploying firewall rules that eventually block port numbers that both Windows Server Failover Cluster and SQL Server data replication traffic, the HADR underscore endpoint port. Again, these are things that they do as part of their day-to-day that they're not aware, or maybe they are, but they didn't bother asking you. Okay. Again, mentioning earlier the backup admins, enterprise backup admins, they are taking enterprise backups, not knowing that the amount of time it takes to take a backup would impact heartbeat communication, which in effect take the cluster offline because it loses quorum, technically losing quorum. So these are operational assumptions as well. Bottom line is, whether you're in the early phase of the design, or somebody else gave you the design and all you have to do is implement, or you're now in the day-to-day care and feeding of your availability groups, failover clustered instances, or any type of SQL Server high availability and or disaster recovery solution, bring the other teams in a conversation, even if they feel like they don't need to be a part of that conversation. Bring them in the conversation. Bring them in as early as possible. If you can, talk to your manager. Let your manager reach out to the other teams. Have these types of conversations. Make sure that everybody involved, not just in the deployment and implementation, but also in the day-to-day operations, including the operational staff in your help desk team. Make sure they're aware. They're part of the conversation. Again, the last thing you want is for the help desk, they get a ticket, they don't know how to categorize it because they don't know. Is this a database issue? Is this a SQL Server issue? Is this a failover clustering issue? They wouldn't know. As far as they're concerned, the databases are offline and they're not aware of what the issue is. Bring them into the conversation, educate them, inform them so that you have a streamlined operations to achieve high availability. You probably realize that all of these things, while technical in nature, pertain to people. Because the reality is, the weakest link in any high availability and disaster recovery implementation are humans. It is us, humans. If only we can eliminate the humans in the equation, but we can't. So bring those people in the conversation, bring them into the communication early on to make sure that you do achieve high availability and or disaster recovery goals. So you don't have to worry about, oh, why is my failover cluster not online when it's supposed to be highly available? Okay? That is about it, because I need to wrap this up, otherwise I'm going to keep going on and come up with all the other cases that I've seen with the situations and the rationale behind why always on is not always on. It's almost on or never on. We have this running joke about databases running in an AG because, again, it's offline, it's causing more outages, not realizing it, again, it's these kinds of things, okay, that is the traps. And you might be thinking, wait a second, you did say failover clustering, right? Yes, because again, it's always on available groups. Failover clustered instances rely on failover clustering for high availability. Okay, that is about it for this episode of the Practical SQL Server HADR show. Tune in again next week. And next week, I'm coming up with a brand new, I want to say mini-series. Because again, talking to customers, having these conversations, I get a sense of what the most common things are. There's a pattern. So I am going to come up with a new mini-series next week. So keep posted on what that mini-series is. And if you need help with anything regarding either always on availability groups, failover clustered instances, or any type of SQL Server high availability and or disaster recovery solution, reach out. Use that link on the screen. Schedule what I call a strategy session. And we are going to be doing two things during that about 45 minutes to an hour call. First is we are going to get clear on what goal you're trying to achieve. Because I do not recommend always on available groups lightly. Okay, we are going to get clear on what goals you're trying to achieve, what problems you're trying to solve. So that's the first part. The second part is to come up with a step-by-step plan, a strategy to make sure that you're achieving those goals and or solving that problem that you are recognizing. Because again, most people think, oh, this is my problem, not realizing there's a much deeper problem. Okay, we are going to get to the real issue and help you solve those real issues. Use that link on the screen, schedule a strategy session, and let's have a conversation, and happy to help in any way I can. That is about it for this week's episode of the Practical SQL Server HADR show. Tune in again next week for not just another episode, but another mini series with a certain theme. Watch out for that. So enjoy the rest of your week, and wherever you are, might be a long weekend. And I'll see you again on the next episode.